So quantitatively, this is 1.3, and it is about percent increase. So it says the percent increase, sorry, let me get my mouse straight here. The percent increase is not just an increase in the original amount. It's a comparison to the original amount. Let me go into that a little further. You don't just change the original amount, you increase it or decrease it, as we'll get into this, by a percentage, a portion. So you know that one is a quarter more or a half more or half less or a quarter less. So the amount of change is equal to the new amount minus the original amount. There is a formula to find the percent of change. You take the amount of change, I'll abbreviate here a little bit, the amount of change, divide that by the original amount, and then multiply that number by 100. And that'll give you the amount of change. So in this first example, it says, find the percent increase from 10 to 15. So on step 1, I need to find the amount of change. Well, in order to find the amount of change, I take the new amount minus the original amount. So I went from 10 to 15. 15 is the new amount. So 15 minus the original amount, 10. So the amount of change is 5. Then I want to, in step 2 of this problem, find the percent of change. The formula says that I take the amount of change, which we just found right here to be 5, divide that by the original amount, which was 10, and then multiply that number times 100 to get the percent. So 5 divided by 10 on your calculator, you want decimals here, you're not wanting fractions, is 0.5. When I multiply that by 100, basically moving that decimal place twice to the right, as I multiply, I wind up with a 50% increase. So yes, it increased 5. That's the amount of the change. But the percent of the change was 50%. It went up 50%. Just like if you made 50% more per hour. Say you were working for $10 per hour and you got a raise. Now you're working for $15 an hour. So your amount per hour of change would be $5. But the percent of that change would be your salary increased by 50%. Example 2. The population of a small town changed from 125 to 150. What is the percent of increase? You try this problem using this model above. See if you get the right answer. Come back to the video in a minute and check your work. Okay, so the amount of change is 25. Because 150 minus 125, that gives me the amount of change. Here's another way to do this. You can put a calculator in one step if you need to. Just go ahead and put parentheses around everything like that. But 150 minus 125, that would give you your amount of change. The original amount was 125. That's what you're going to divide by. Then you're going to multiply that whole thing by 100. So when you do this, you're going to find that all of this is 0.2 times 100 gives me a 20% increase. You'll see it written like that sometimes. Percent and an up or a down arrow for increase and decrease. Okay? This is not a real hard lesson. Just try to stick with it. Won't you pause this video and try this example 3 and then come back to the video. Okay, welcome back. So it says that Mariah's house has appreciated. Appreciation means it went up in value. So this is a percent increase. It's another important thing to learn is the words that are associated with increase. It has gone from being worth $125,000 to $175,000. What is the percent increase in value of Mariah's house? So you take the new amount. We can do thousands, but since they all have 3 zeros at the end, you can drop that if you want, but I won't for this example. Minus 125,000 all over the original amount, what it was worth. Now, when you put this in your calculator, you're going to get 50,000. Terrible writing this little marker, but I want you to be able to see from now on. So, divided by 125,000, which is 0.4. And don't forget, then once I get that decimal, I have to multiply it by 100 to find the percent. So the percent is now 40. Multiplying that, by 100 moves the decimal place 2 times to the right. So it has a 40% increase. Before we start percent decrease, I'll give you one more problem. Find the percent of increase from 35 to 90. This is like an example, extra example. 35 to 90. You pause your video and give this a try and come back for the answer. Extra example problem here. 35 to 90. So remember that's 90 new amount minus 35 all over the original amount, which is 35. That winds up being 55 divided by 35. And the decimal for that is 1.57. This next number is 1. So we're going to stop it right there. Okay? We want a whole percentage in this one. If it said to go to the tenths, I need to put that 1 there. But I'm not today on this. Then I'm going to multiply that by 100 to find the percentage. So I'm going to move this over. Is it possible that something increases 157%? Yes, it is. If something increased 100%, it would go from 35 to 70. It would double. But this went more than 100%. It more than doubled. So the difference here is 55. The new amount minus the original amount divided by the original. The difference there is 55 divided by 35, which gives me 1.57. That's 157% increase. If you need to ask me questions about that, reach out through email. Okay, the next part of this lesson concentrates around percent of decrease. So the percent of decrease plays a huge role, especially this time of year around Christmas, in discount pricing. So when you go on Amazon and they say everything from this website is 32% off, here's how you find those amounts. Or if they say this is decreased, but they don't tell you by what percent. So you take the new amount minus, that's a minus sign, minus the original amount. And that is a percent of change where we take it's the same thing, except we're going to have a decrease. We're finding decreases this time. So you take the amount of change, which we found in the last part of this lesson, and divide it by the original amount. Just need to remember that now we're looking at going down. So an example, Jean bought a new car for $16,000. 1 year later, its value was 13,600. What was the percent of decrease in the value of car in the 1 year period? So you take the new amount, 1360, 13,600, sorry, subtract the original amount of 1,600, divide that by the original amount, and then multiply the whole thing by 100. Same process as before. Here's the kicker. This time when I take the new amount and subtract the original, I'm going to wind up with a negative amount divided by 1,600. Sorry, that should be 16,000 up there. My bad. And I apologize for that, for dropping that zero. No excuse for it. Then I'm going to multiply that by 100. So in my calculator, I'm going to wind up with negative 0.15 that I'm multiplying by 100 now, moving that decimal place twice. And if I get a negative, which I'm going to, 15%, that means it's a decrease. Positive percent changes are increases. Negative percent changes are decreases. That's important. In fact, I see them asking questions about this so that they can determine if you understand what percent of increase and decrease are. So you pause the video and try number 6 and then come back for the answer. Okay, so we're back for this problem. A little different, not much different though. All we need to know here is that we know the percent of decrease. We know that. The decrease percent was 40%. Weight loss is a percent in decrease. So we've been finding with this formula the percent decrease. We can use that same formula to find out what the original, wait a minute, if the camel starts off weighing this, how much will the camel weigh after? So we can find out its new weight. But you know that to find 40% of 1,200 is a simple task. Change that percent to a decimal, multiply by the original amount. So that means that camel lost 480 pounds. So now you take this 1,200 minus 480 and find out that the camel now weighs 720. I don't think that's probably a good healthy weight for a camel. A couple of more examples that you can try. Pause your video and try is, what if you went from $80 an hour, you were making $80 an hour, to $65 an hour. Say your employee says, I love the work you do for me, but I can't pay you $80 an hour. If you want to keep your job, I'm going to give you $65 an hour. Still a pretty good pay, but try that one. See what you get for an answer. And here's another one. What if you went from 110 toy cars, kind of a kid's thing, but down to 4 toy cars? How many did you lose? What percent did you lose? Pause your video, get an answer to the 2 of those, come back and check your work. Okay, so here's the 2 answers to those problems. I didn't write negative because I know that when I get this answer, it's a negative. It's automatically a percent decrease. It dropped 18.75% in your salary. If you're going to live off that, yay, I could live off that. I'd be happy making $65 an hour. And then if you lost all your cars but 4 out of 110 set collections, let's say they got stolen by your little brother, and they were your little collector's cars, then you lost 96.36% of your car collection, or rounded to the nearest tenth, 96.4%. So, a couple of things about a couple of applications for percent of change that you use every day in the store. When you go buy anything, you have to pay sales tax on that item. That's a percent increase. And if you're a discount shopper, if you're going to shop the sale rack, you're getting a discount. So discount is a percent in decrease. And remember that when you're given a percentage, like in this problem here, I took that 40% and converted it to a decimal. Now that was in a previous lesson. Let me show you one more time. 40% to a decimal. Either move this decimal places 2 times to the left and get 0.4, or 3 divided by 100 will give me that 0.4 also. Okay? So remember to convert your percents to decimals when you start working problems. There's a few more examples on here. Like number 7 is kind of a 2-step problem, so we'll do it together. And then number 8, you can work on your own, come back and check your answer. So number 7, and if you want to try it on your own, right now is the time to pause the video. And if you want me to work it with you, come back and watch it. Or if you just want to continue watching the video, hang tight. We're going to be done in about a minute here. So the first thing that we want to do is read the problem. Shana's purchasing wire and beads to make jewelry. Her merchandise is $28.62 before tax. If the tax is $7.25 of the total sales, what is the final cost? Well, first, we need to find the tax amount. We know the percentage of tax, but we don't know how much money that is. So we're going to take this amount, 28.62. We're going to multiply that by 7.25%, right? We're going to convert that 7.25%. I need that in decimal form. Move this twice, get 0 in the front. So we're going to multiply that by 0.0725. And then we're going to find that we're getting a $2. We're paying $2.7495 in sales tax. Now you know that we're going to stop right there with the sales tax. And that's not 5 or better, so they can't make us pay 8 cents right here. We can only pay $2.07. So then the next step is to find the cost with the tax. Okay? So the item cost $28.62. We're going to add this tax to it, $2.07. That's what your bill should be. That's what you should give the cashier. They hit you $35 and some change. They've charged you too much. You don't know how to figure your sales tax, and some people are not always honest. They may not be watching. They may think, oh, well, they don't know how to do that, so I'll just cheat them. It's possible. At least you know when you're getting cheated this way. Okay, try this problem and come back for an answer to that. Okay, so there's the final problem, the answer for the final problem. If you didn't get that, turn the video back off, try it again, and then come back and check it again. This is not a hard lesson. There is a Google form for it. So good luck.